Hey guys, this is Mrs. Field. On these notes today, I wanted to talk with you because these notes are on enzymes, and enzymes we are going to probably talk about all year. So I thought it was pretty important, and I just wanted to make sure that everything was covered. So while you were going through this Nearpod, I will occasionally hop back on and tell you something on a slide and make sure and copy this part. Attached to this assignment, I attached a PDF. If you have a printer at home and you want to print it out, it was just sort of an outline to take notes. But if you don't have a printer, maybe just take notes in a journal someplace that you can easily access, because we will probably pull these out occasionally, and maybe you could use these later on in a pop quiz or later on when we bring something up and we just say the word enzyme. So here we go. Okay, so these notes are about enzymes, and if you remember a few weeks ago, we were talking about how DNA makes a copy of itself, which is called DNA replication. And in DNA replication, we mentioned several enzymes. We said they ended in the letters ASE or ACE. And so these enzymes that we mentioned, like we mentioned when DNA unzips, it's the enzyme helicase. Since DNA is a double helix, it's helicase that unzips the helix. Well, what exactly is an enzyme? We kind of mentioned them, but we didn't really go into detail, so that's what we're doing today. Enzymes are proteins, and they're special proteins. They really have a really important job because they are proteins that help molecules react with one another. Since they are proteins, they are made of smaller subunits, which we call monomers, meaning one small unit, a monomer. This, for proteins, they're called amino acids. So, trying to go to the next slide. Hang on just one second. There we go. Okay, so what else is an enzyme? An enzyme is actually used by a cell to trigger and control a chemical reaction. We'll get into chemical reactions and try to jog your memory about that in a second. But if they control a chemical reaction, what they can do is they can actually speed things up or they can slow things down. Primarily, they're used to speed things up. Without enzymes, several reactions would never occur in a cell, or they would happen so slowly that it wouldn't do the cell much good. And some things you just need to have happen quickly, and an enzyme will do that for you. So enzymes have a special job. You often can tell if something in biology is an enzyme because it's going to end in ASE, kind of like when we talked about DNA replication. We had the enzyme helicase, and it ended in ASE. We had DNA polymerase, and it ended in ASE. Some other enzymes you might have heard, lactase. That is associated with people that are lactose intolerant. So a lot of times the enzyme is named for whatever chemical reaction it helps with. So just so you can easily spot them, they end in ASE. So now, what is a chemical reaction? Let's jog your memory back to 8th grade, or if you had IPC last year in 9th grade maybe. So a chemical reaction is just where you have, and if you look at the screen over here, you will see it has hydrogen peroxide on the left side, and then on the right side, you have water and oxygen. You still have the same number of hydrogens on both sides and the same number of oxygens on both sides, but if you notice, they're arranged differently. So on the left side, they're all together. They're actually hydrogen peroxide, a chemical, and on the right side, it's actually two substances. It's water and oxygen. So So a chemical reaction is when you rearrange the atoms, and on both sides of the equation, you don't have the same thing. You may have the same number of atoms, but you don't have the same thing. So how do I know a chemical reaction took place? If you guys remember back to 8th grade, oftentimes you would probably do chemical reactions like mix baking soda and vinegar, and you knew a chemical reaction happened because you saw bubbles. You sometimes could feel a temperature change and it would get really cold or maybe get really hot. Sometimes a color changes. Sometimes it emits an odor. There was a saying in 8th grade that oftentimes at China Spring, when I taught 8th grade, I would teach the kids and I would say, city girls love their smartphones. And that was a way to memorize clues that a chemical reaction took place. And if I took the first letter, city, C, that means that a color change might have happened. City girls, G for girls, G, a gas would be emitted. Think of baking soda and vinegar. Usually a gas is emitted, and I know that because bubbles bubble up. City girls love is an L, meaning like a light sometimes is emitted in this. You see that in fireworks when the lights in the bang in the sky. Actually, fireworks have lots of signs that chemical reactions took place. So city girls love their T was a temperature change. It got really hot or really cold. City girls love their smart. Sometimes a smell would emit from it. Sometimes that's good. Sometimes that's not so good. City girls love their smartphones. And finally, P was a precipitate, like a solid. If I think of fireworks, when you light a firework in the sky, they have all those things. There's a color change. There is a gas emitted. You see the smoke. You see a light emitted. You can smell fireworks from a distance away. So that's just how we knew a chemical reaction takes place. What is it really? It's a rearrangement of atoms, meaning that usually a bond was broken and a new one was formed. Okay, I'm going to stop my video and let you watch a video that tells you something that catalysts do, something about an activation energy. So on the next slide, let me switch it for you real quick. An enzyme is also known as a catalyst, which is a very fancy word. And basically, catalyst means that you speed up that chemical reaction. You make it happen faster. And how it does that, it actually lowers what we call the activation energy. It participates in the reaction, but at the same time, it doesn't change itself. And so the enzyme can go on its merry way after the chemical reaction. It sort of joined in for the party, and then it left the party, and it can join in again and again, which is kind of a weird way to think about an enzyme. But I'm going to stop the video and let you watch a video, and it's about activation energy, and they explain activation energy a little bit better than me, so you can see a graph, and I'll be back after the video.